All right, y'all. So today we're going to be talking about balancing chemical equations. But before we do, I just want to go over a point real quick called nope, not that, the conservation of mass, sometimes referred to as conservation of matter. But pretty much what it says is the atoms on both sides of a chemical reaction will be the same. More specifically, we can't create or destroy matter or mass. It's always conserved. But basically what that means is regardless of the orientation, if I have hydrogen and oxygen on one side, I must have hydrogen and oxygen on the other. And furthermore, there must be the same amount. So if I have H2O, I've got a little water molecule right here, then I should also have enough here to make a water molecule. So I actually would need one more hydrogen. So I'm just going to go ahead and slap a big 2. That means I have 2 individual hydrogen atoms bonding with one oxygen atom to make H2O. So that is the general concept of conservation of mass and the general concept behind balancing equations. But before we move any further, we have to clarify a couple of things. So I'm going to once again use my example of water. So if we look at water, it's got a couple parts to it. We have this little number down here. And this number is what we call a subscript. A couple things about subscripts. They cannot change. So H2O is always H2O. It is not H3O. It is not H2O2. It is H2O. We cannot change the subscript. When we change the subscript, it becomes a different molecule. And we cannot change the molecule because that's not what we're doing. So the subscript cannot change. It also refers to the atom in front of it. So this 2 is going to refer to the H. It tells us how much there is. I'm going to use arrows. It tells us how many of the element in the molecule. So for H2O, it tells us we have 2 H's and 1 oxygen. It is 2H and 1 O. And we know that from the subscript. So that's all the major stuff about the subscript. All right. Now, once again, we're going to go to the next part. We're going to look at H2O again. And we're going to look at this spot right in front. We don't really see anything written, but this spot right in front is actually what we would call the coefficient, which the coefficient, always 1 if not written. So if there's no written coefficient, we just assume that it's actually 1. And what this does is it tells us how many of the whole molecule we have. It tells us how many of the whole molecule we have. And this is super important because having 1 water molecule is good, but sometimes we could have 2 H2O, which tells us that we have 2 water molecules. They are separate. They are each their own entity, but in total, in 2H2O, we have, we'll start with hydrogen. We have 4 hydrogens and 2 oxygens. Just because we have 4 hydrogens and 2 oxygens, however, 2H2O is not the same as H4O2. This is not the same. They are not the same. So remember, coefficients tell us how much is in the whole molecule, but it does not change the molecule. So I'm actually going to add one more thing here. And I'll move this guy up. I'll move it down here. So one more thing with coefficients is these can change. In fact, all we'll be doing today is changing coefficients. And it's pretty much as simple as taking one water molecule and then just adding another into your equation. We are not changing any amount of compounds. We are just changing the amount. So when we try and make something fit conservation of mass, we call that balancing a chemical equation. So if we are balancing a chemical equation, well, first things first, we're going to need a chemical equation. So we're going to take the one from before, but change it a little bit. So in reality, if we are forming water, we actually have to start with H2 and O2. Hydrogen and oxygen, really quickly, are both diatomic, which means they only appear in molecular form with 2 of them. Diatomic, di meaning 2 atomic atoms. But that's not super important right now. Just wanted to put that in. So it's H2 plus O2 makes H2O. So we'll draw one H atom or one H element. We'll draw another O. And then we'll draw the final thing, H2O. So when we look at this, we have 2 hydrogens, 2 oxygens, and then 2 hydrogens and 1 oxygen. Oh, go ahead and put the O. So the problem with this is our oxygens are off, and we're not allowed to change the coefficient. I cannot put a 2 here. That doesn't work. So what I'm going to do is actually change this number in front. If I have 2 H2Os, then I can just go ahead and add another one of these. And now we have 4 hydrogen and 2 oxygen. And this is great because now we can see that we only need to change our hydrogen. So my bad. And we can do the same thing we did before with H2O. And now we have 2H. No, mistake. Now we have 4 hydrogen, and this is what we would call a balanced chemical reaction. So our coefficients are 2, 1, 2. And this is fully balanced, and we're happy the way it is. So we're going to try something a little harder, and I'm going to now show you the method I use to balance an equation. We'll do the decomposition of ammonia. NH3 becomes N2 plus H2. Both of these being diatomic as well. And what I like to do is I like to make this little column right in between this arrow where we have our reaction actually taking place. And this little arrow divides our reactants, the stuff on the left, from our products, the stuff on the right. And then what I'm going to go ahead and do is put each atom or each element that appears. So we have nitrogen and hydrogen, and I'll write how many appear. So on the left side, I'll write how many appear, and on the right side, I'll write how many appear. So let's start with nitrogen. I only have 1 nitrogen, and then hydrogen, I have 3. On the right side, I have 2 nitrogen and 2 hydrogen. Then what I'm going to do is see what I can multiply each of these by to get the other number. And I start from the top. So I'm going to start with nitrogen, and then I go down to hydrogen, and I'll just keep going back and forth through. So I can see that I can multiply 1 over here by 2, and that will get 2. So I actually don't have to multiply the right side by anything. So if I'm multiplying my nitrogen by 2, I need to find out where nitrogen is. And it's only in one possible place. Furthermore, I am now going to change my coefficient because I can't put a 2 there. That doesn't work. We've already talked about that. No subscript changes. But I can put a 2 here. So now I'm pretty set. And I'll actually go ahead and show that by just replacing this with a 2 nitrogen. The one problem that you may be saying is, but that 2 affects the hydrogen too. And you're exactly right. This 2 affects the nitrogen, but also the hydrogen. So instead of having 3 hydrogen, we now have 6 hydrogen, because 2NH3 is 2 molecules of NH3. So it's 2 times 3, which is 6. So with that out of the way, let's now see what is good and done. So if I go ahead and look at my equation, nitrogen is all good. It's all balanced. I can give it the little check mark. But hydrogen's still not. And now I have 6 on one side and 2 on the other. Well, I can still multiply one side by 3, and that's going to get me my 6. And so what I'm going to do is look for hydrogen, because now I'm working with hydrogen. So I see that I'm with hydrogen, and I'm on the right side. So I have to find out where my hydrogen is. And well, it's right there. So I'm just going to put this 3 right there. And it only affects the hydrogen. So I can go ahead and change all this and rewrite it as a 6. And looks like we're balanced. So my coefficients are now 2, 1, 3. And we're done. That's it. All right. So finally, for the last one, I'm going to do it, and then I'll show you a kind of easier way to do this as well. We're going to look at C2H6 plus O2 reacts to form H2O and CO2. So before we get started, I'm going to kind of just give one general rule of how we're going to do this. So I'm going to put CHO because we have a C, an H, and an O, and we should have a C, an H, and we actually have 2 O's on this side. When you're balancing, and this is pretty crucial if you don't want to mess up. The best way to say this, actually, let's do this. If an element appears in more than one place per side, balance it last. So what I mean by that is I see carbon only in one place on the left and one place on the right. I see hydrogen one place on the left, one place on the right. I see oxygen one place on the left and 2 places on the right. And because it appeared more than once per side, I'm going to balance oxygen last. And we'll see why that is in just a minute. So let's go ahead and get down our numbers. We have 2 carbon, 6 hydrogen, and 2 oxygen. 1 carbon, 2 hydrogen, 3 oxygen. 3 because we have 1 from here and 2 from here. All right. So first things first, let's see if I can multiply anything by, and I'm going to start from the top and then work my way down. which oxygen's already last, so that's nice. So I know that I can multiply 1 by 2. That'll get me 2. So I have to find carbon on the right side. So it's right here. So I'm going to go ahead and put a 2 there. That 2 is going to affect the carbon, but also the oxygen. So while carbon is sitting at 2, oxygen now goes from 2 times, it'll go from 2 times 2, which is 4, plus the one from over here. So carbon's actually going to, or oxygen's actually going to become 5 now. But carbon's balanced. So we can go ahead and check that one off. All right. Now, for the next one, we have hydrogen on both sides, and I can see that I can just multiply that by 3 to get 6. So I'm going to go ahead and find hydrogen on the right side. So it's right here. I'll go ahead and put my 3 in. And once again, this 3 is not only going to affect the H, but also the O. So now I have, while I have 6 hydrogen, I have 3 times 1, which is going to be 3 oxygen, plus 2 times 2, which is going to be 4 oxygen, for a total of 7 oxygen. So I'm going to cross it out, and I'm going to put 7. We're all done there. All right, so now we're on the last one, oxygen. And in my heart, I know that I could just multiply this by 3.5, but the problem is we can't really use decimals for coefficients. And a quick example of why is if I go ahead, oh, I just need to move this around. If I go ahead and write 2.5 H2O and we draw that out, we have 1, 2, and then 0.5. That's nothing. You can't split an atom. We can't have half of an atom or half of a molecule. We have to have the whole thing. In fact, because I stopped drawing this oxygen right here, it kind of actually looks like a carbon, which this doesn't make sense. No, we can't have it. So we have to figure out something else. And so the quick solution here is instead of putting 3.5, why don't we just, well, I know 3.5 wouldn't work, but maybe something else will. Well, what if we start adding to other coefficients? So I can go ahead and maybe go back on my word. Maybe we're not done with these. What if we go ahead and start by doubling our initial amount? We can bring this to 4. We can bring this to 12. And now when I go back through these coefficients, I can actually instead multiply our carbon by 4. And now I'll have 4. And that will balance out. So my coefficient here will be 4, which is now going to change my oxygen. So instead of starting at 3, we now have 4 times 2, which is going to be 8 plus our 1. That's actually going to be 9 oxygen. Then to get to 12, we're going to multiply by 6. That'll give us 12. So I'll go ahead and change my coefficient to 6. But again, that's going to multiply my oxygen. So now we have 6 oxygen plus 8 oxygen, which is equal to 14. See, now this balances. Instead of 3.5, 2 can actually multiply by 7. You can get 14. So now we know our coefficient is 7, and we are done. Our balanced equation now looks a bit like this. 2C2H6, 7O2 reacts to form 6H2O plus 4CO2. So there's one last thing I'm going to say about this, just to kind of make your lives a little bit easier as well. I'm going to take our example. We're going to go back to what we had before. We're going to go back to the fraction, the decimal that I didn't really like. CHO 262. And we had our coefficients, I believe, of 3 and 2, which brought this to 6, which brought this, or sorry, which brought this to 2, 6, and 7. So you're doing your multiplication and you're at 3.5. One of the things you can do is just accept it. Say, fine, I'm going to break the rule Mr. Garcia just laid out and put a 3.5 there. Well, if you know that you can't use whole numbers, which you cannot use whole numbers, you say, okay, that's fine. If I multiply all my coefficients by 2, well, then we can kind of see that this just kind of all ends up working out anyways. I get 2C2H6 plus 7O2 makes 6H2O plus 4CO2. And it still works out. We still have a balanced equation. And on top of everything, you don't have any decimals. It's all whole numbers. So I go home happy, you go home happy. So that just takes a little bit of math and a little bit of knowledge of ratios and proportions. But otherwise, this stuff isn't so bad. So have a great day, and I'll see y'all next time.